is very, very important because when we work in neural network, all those things is definitely it impact a lot, guys. Are you understand? So the first thing, what is gradient descent? What is stochastic gradient descent? Let's understand, and we discuss all those things one by one. And I want anyone to make a every class. I want to take anyone, okay, to make all the proper documentations. I'll give some persons, and then you guys can take care of it. Okay. Anyway, I'll tell you. So what exactly this gradient descent? So do you remember we talk about one of the concepts to reduce the loss? What is meant by that? Reduce the loss. What is meant by that? Guys, are you understand? You both are understand or not? Okay, so reduce the loss means, so assume we, this is actual point, this is model predicted. This is actual point, this is model predicted. This is actual point, this is model predicted. So here, when we plot the line, the minimize error isn't backward eliminations, yes, reductions, right? So here, what we do, the distance between y and y hat is loss or not. So when all the points are closer to the line, we get a best accuracy. We get a best accuracy. So that's why there is a statement every times I will say this statement that we reduce the loss. Loss means y minus y hat to get more accuracy. To get more accuracy. So what is gradient descent? Gradient descent is an optimization algorithms to reduce the loss functions and reach the global minimum and reach the global minimum. This is very important, guys. And when you attend some of the product based interview questions, sometimes they will ask you, can you please build any algorithms without using sklearn? Understand, guys? Can you write any algorithms without using sklearn? So how to write this, all those things we will understand today. And this session is very important. Gradient descent we can use in ensemble learning, and also in the deep learning we've been use it, guys. And in deep learning we will use this. I hope you guys are clear. So here I will give you these explanations in two part. Understand? Gradient descent I will explain in two part. First part, you not understand. You not understand. Second part, it's completely math. If you listen well, then this concept is easy. If you not listen well, then you never ever understand this part. Are you guys clear? All right. So let's go ahead and we can heading toward this one. Let's close this and I minimize it. So the first part is gradient descent. Now listen to this, what exactly I'm saying. Try to reduce the loss to reach the global minima. I have one equations, y equals to mx plus c. Isn't it? Y equal to mx plus c. So if I feed these values, 1, 2, 3, 4, 5, can I get this output or not? This is traditional programming language. This is called traditional learning. Means we feed input and already logic is defined and we get output, isn't it? So this is called, traditional learning. Now heading toward this one. X equal to 1, 2, 3, 4, 5. Y equal to 5, 7, 9, 11, 13, isn't it? So we feed input and we feed output. So the machine is generated logic, which is called y equal to mx plus a. This is machine learning or not? This is called logic. This is called model. And this is what we keep learning about. So just close this one. Now, next step. Okay. Did you see the global minima graph looks like a bowl shape? So my question, if I drop a ball here, if I drop a ball here, what happened, guys? The boys come down and goes up and come down and goes up and come down and goes up and down and up, down and up. Finally, it will reach the, this point is called global minima. This point is called global minima. So here, what is meant by weights? So whenever the up and down, the weights are generated or not, guys? In the world, each and every actions, there is a weights are associated with it. For example, if I have three records, 1, 2, 3, what is the weight of the records? I can say 1/3. What is the weight of the records? I can say 1/3. 1/3, isn't it? Do you remember in school days, we living in the earth, we also moving along with the globe, isn't it? So here, so the same thing, this weight. So what exactly this one? I'll give you this. So here, the question is, we have multiple line here. We have multiple line. But my question, how to find out the best fit line? What is the answer for that? Because what is the best fit line? Let's minimize the MSC to get more accurate. Minimize the MSC to get more accurate. Did you see this is also called as delta, means actual minus predicted, actual minus predicted, actual minus predicted. And I can say 1 by n summation ni equal to 1 delta I square, isn't it? So this formula also called as MSC. What is MSC, guys? Mean squared error. MSC means mean squared error. Understand? So also we called as OLS. Also we called as OLS, ordinary least squared. Ordinary least squared. I guys understand? Also we called as cost functions. Did you see what we called, guys? Cost functions. Or also we called as loss function. So in interview, if anybody asks what's meant by MSC, what's meant by OLS, what's meant by loss functions, what's meant by cost functions is very important. Now, if you understand this cost functions now, in futures, whenever we talk about deep learning, these things is very interesting. Clear? So all the answer is only one, difference between y minus y hat whole square. Clear, guys? So this is all about the equations, which is called mean squared error. Now the next one. Gradient descent is an algorithm that finds best fit line for given training data set. What exactly, guys? Gradient descent is an algorithm that finds best fit line for given training data set. So GD graph, gradient descent, always plot in 3 dimensions graph. How many dimensions graph? 3 dimensions. What is meant by 3 dimensions? I'll show you. So here, if you see, did you see this is 3 dimensions or not, guys? So what exactly things we have all the X, Y, Z? I mean to say that in X-axis, we have slope. Okay. And in Y-axis, we have intercept. Do you remember Y equal to mx plus b? So here, this is M, isn't it? This is B, intercept. Now, this is called cost. This is called cost. So now I will come back and give you. And finally, the end of the day, we try to reach the global minima or not. And this line would be the best fit line. If you make the 3D to 2D, you will get the graph like this. Are you getting my point? What I'm saying? If you convert 3 dimensions to 2 dimensions, then you got this graph, guys. Then you got this graph. Online team, I hope everybody's understand. Yes, guys? Okay. No comments. Great. Now let's heading toward another one. Okay. So, but my question, how do we plot this graph? I'll give you one simple math. I want you to understand well about this math. And then we talk to the point. Then we come to the point. Just close this. So let's start with simple data set. What do we do, guys? So let's start with simple data set. So assume I have 2 dimensions graph. This is math. Try to understand. Then GD is clear. Gradient descent is clear. X-axis is weight of the person. Y-axis is height of the person. Isn't it? Y-axis is height of the person, x-axis is weight of the person. And is this data points are actual or not, guys? Can we call this is data points or actual data point? Yes, this is actual data point. Now, next step. In statistics, machine learning, okay, we optimize a lot of stuff. I'll show you what are those things. Now, when we fit a line with linear regressions, we optimize the intercept and slope, isn't it? When we plot the line here, we optimize the intercept and slope. So assume this is actual point, this is model predicted. What exactly, guys? This is model predicted. In simple linear regressions, we plot the best fit line or not. So that line is predicted by your model. So assume, so this is actual. So can I mention height equal to intercept plus slope into weight? Y equal to mx plus c. Know these equations. Now next one, next step. So I don't talk about this, all these equations at this moment. Okay, logistic. All right, guys. So here, before I go back, look at this. On the x-axis, we have weight, isn't it? Next one. On y-axis, we have height. If I fit a line to the data, assume someone tells that the weight of the person is 1.5. So can I say this is 1.5? 0, 1, 2, 3, 4, isn't it? So 1.5 is this, the point will come. Okay, now close this. Next step. If 1.5 is weight, can we predict the tall or not? If I plot the points, the tall is what, guys? 1.9, 0, 1, 2, 3, 4. Again, the height of the person is 1.9. Understand up to this, everyone? Okay. Now, next one. Next one. We can use the line to predict that they will be 1.9 tall. Now, let's assume, so can we fit these equations? Y hat equal to mx plus c. So let's assume intercept is what, guys? Constant. Intercept is what, guys? Constant. And slope is what? When the best fit line touch to the y-axis, we generate a slope which is called, every time, all the time, this side slope is positive. This side slope is negative slope. Are we understand this graph? I mean, in 10th class, I hope we clear all the points. Now let's assume, so at this understanding the gradient descent, let's consider slope of the graph is 0.64. Slope of the graph is 0.64. Next one. And once we slope of the graph is 64, just one moment. So assume the intercept, if the best fit line touch to the origin. So intercept is what, guys? 0. So can I say this? I mean to say y equal to mx plus c. So if y equal to 0.64x plus 0, can we write this? So now here, what happened? So finally, I get my equation as, in this example, we will understand how we learn what is sum of square residual. Sum of square error, everybody knows, guys. But what is sum of square residuals? I told you when I start gradient descent, I will explain you in detail, isn't it? So if this is actual point, this is predicted point or not? If this is actual point, this is predicted point. If this is actual point, this is predicted point. Can I say this yes or no? In this example, we understand how the line fits the data with sum of squared residuals. I mean to say, just go ahead. In machine learning lingo, the sum of squared residual is a type of loss functions. Understand? Is a type of loss functions. Now let's assume we will compute one by one. So how to compute the difference? How to compute difference? Just go ahead. So if this is actual height or not, guys? This is actual height or not? Assume the data actual height of a person is 0.5 is weight, 1.4 is height. Clear? XY coordinate 0.5. And now if this is actual, let's predict what is the predicted. Now, is this predictions point or not? Is this predict? Now, what is the predictions point? Y hat equal to mx plus c. Now, the predicted point we calculate sum of square residuals. So here, predicted height equal to mx plus c. What is slope? We considered 0.64. And intercept is because the best fit line touched to the origin. When the BFL touch to origin, so definitely the intercept is 0 plus weight. What is the weight of the person, guys? 0.5 or not? Because this is 0.5, 1.4 means the weight of the person is 0.5. Now the predicted height equal to 0.32. Break the height, it is 0.32. Are you understand or not? So this point is 0.5 comma 0.32, isn't it? The next one, what is residual? The residual is observed height minus predicted height. What is actual height? 1.4 minus 0.32. This is called predicted height. So here, MSC, what is MSC formula? So 1 minus 1 whole square or not? So here, can we do this? For this data point, the sum of squared residual is 1.1 whole square. For this point, sum of square residual is 1.1 whole square. Are you understand, everyone? Online team and offline team? Online team and offline team, everybody's clear or not clear? Okay, so I will explain once again, guys. Today, we started with gradient descent concepts. Okay, what is gradient descent? So gradient descent graph looks like I said this concepts I'll explain in two parts. What is the first part of the explanations? This is what we discussed. Now, what is the gradient descent? Gradient descent is an algorithms that finds best fit line for training data set. Okay, I mean to say that. So here, as we discussed, if you drop a ball, the ball will goes up and down and it'll try to reach the global minima. And this would be the best fit line. Understand, guys? And that would be the best fit line. So here, so how to reach global minima? We try to understand the math. So what is the math for this? Just now we covered up. So assume we have 3 data point. Take random data points, guys. In the 3 data points, what happened? In the 3 data points, we have weight of the in x-axis and height in y-axis. Height in y-axis. Assume someone weight of the person is 1.5 pound and definitely the height is 1.9 tall. So in this case, assume to understand gradient descent, we take intercept as 0 and slope as 0.64, because if the line touches to the origin, then the intercept is 0 and then slope is, we assume 0.64. Next one. So next one, what exactly happened? We have 3 actual data points. When we fit the line, definitely we get a predictions point as well. Definitely we get a predictions point as well. So in this case, we need to compute sum of square residuals. What we compute? Sum of square residuals. So assume this is actual data point. What is actual data point? In the questions given, we have data set. In the data set, we have X and we have Y. So 0.5 and 1.4. This is actual. And my model predicted. This data represents person with weight and height. Now next step is we get the predicted height on the point of line. So how do you find out the predicted line? So predicted height equal to mx plus c. So c is 0, m is 0.64 and weight is 0.5. When we plug in all those things, and finally the predicted height is how much, guys? 0.32. What is residuals? Observed height minus predicted height. So I mean to say that 1.4 minus 0.32. Then we get 1.1 whole square. So far we compute with one data point or not? So far we compute with one data point. Can we go ahead with other data point? Can we go ahead with other data point? With other data point, assume for other data point, every time we have to do the math. So assume actual data point is 2.3 and 1.9. But when we compute y hat equal to mx plus c, m is 0.64 plus 0 and 2.3. So the residual is 0.4 square. What is the residual, guys? 0.4 square. And the next one, for the third data point, what is residual? Can we continue that or not? Can we continue that? So when we sum up all those things, we get in the end 3.1 is the sum of square residual. So my question, let's plot 3.1 point here. So what is this is called cost functions or not? This point we created when the intercept is 0. I understand. This point is created when the intercept is 0. Now close this. Assume, assume I will plot the graph a little bit constant, a little bit constant. So assume in second line, we have intercept is 0.25. In second line, we have intercept is how much, guys? 0. Did you see the intercept move or not? Now, instead of 0, I'll replace as 0.25. So can you compute the same thing? The computation, can we get same cost functions or different cost functions? You know why? Because the calculations are changed. Because the calculations will change. Definitely, it will be different. Just go to the next one. Here, are we get this another cost functions? Can we do? Can we get this or not? Because the intercept is changed. Now, second one, if I increase another line, now I keep on increasing my intercept. I keep on increasing the intercept. So this here, the intercept is 0, this 0.25, and here 0.50. So every time we keep on changing the intercept. So when we keep on changing the intercept, so what happened? Just go ahead and do this. We get another slopes. Another cost functions. Let's increase to best fit line with 0.0, 0.25, 0.50, 0.75. How many lines we have, guys? So this is 3D or not? So in the first line, I'll plot like this. This is the line. Second line, this line. Third line, this line. Fourth line, this line. Are you understand or not, guys? Or maybe I can say this is the line. All right. And then close. Next one. Did you see? Sorry, check this one, and this is this one. So if I drop a ball, don't you think the ball will drop here or not? So how many? 1, 2, 3, 4. 1, 2, 3, 4, 5. Now let's keep doing this. Let's keep doing this. So if you understand here, what we find, guys, I mean, what we find here, we find here, a, I mean, this is called a curve or not, guys? Global minima. We're trying to reach to global minima, guys. Isn't it? What's meant by global minima? This is called global minima. I mean, if anybody ask how to find out best fit line, okay, minimize the loss functions to increase the accuracy. Every steps, see the gap from this point to this point. The step count is the first step is big or not. Second step is little bit less, and then baby steps are not, guys. Then once we go, we try to get this curve. Team, you understand? So how to do? So this is 2D graph. This is 3D graph. Which one is best fit line? 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is the best fit line, because from this point all the error is accurate, and you get a good accuracies, guys. So there's a two thing to practical, all these things done by math equations or not. Which equation? Simple linear algorithms equations only done. Now my question, what we study right now, we are doing gradient descent. So assume in this concept, if you do this first step count, second step, and when we do keep on step count, we try to reach the global minimum. This step is called learning rate. What we call, guys? Learning rate or momentum or momentum. So this is what your interview questions. The interview question is, there's a two things. When we assign the parameters in upcoming days, we understand there is a concept called XGBoost. In XGBoost, we mention learning rate. So my question, every step, the learning rate is very, very minimum or not? First is big, then small, then baby step. So what happen if the step count is constant? So it take very large time to reach out the global minimum or not? Iteration is very high. Iteration is very high. I mean to say that, assume everybody watching IPL. So there is a line. The bowler is bowling from this end or not? First step, big step. Now small step. Then it doesn't reach to the global minimum. So this is the best fit line. If the ballers are, I'm just giving an example. If for equal step, it might chance to cross the line or not. When you cross the line, what happened? It is a no ball. You understand? So this concept is called learning rate. In interview questions, sometimes you get what is the momentum in gradient descent? What is the momentum in gradient descent? And what is learning rate? Learning rate is used to in gradient descent to optimize the loss functions. And every time the learning rate is very, very minimum. How to assign as a parameters? How the learning rate assigned as parameters, guys? LR equal to LR equal to 0.01. Isn't it very minimum or not? So that's why we call the baby step, guys. I mean, that's why. And also some of the time interview questions, if the step count is equal, can we reach global minima? What is the answer? Yes, but the iterations will be take high. Yes, see, even though you take a big step, end of the goal is minimum only, right? It cannot be crossed every time till the infinity loop it cannot make. Okay, so there is a saturation point where it must need to reach the point, guys, isn't it? So I hope everybody understand what is meant by gradient descent. In gradient descent, if someone asks you, this is an optimization algorithms to reduce loss functions to reach the global minima. And if will you write the algorithms without using a scalar? The answer is yes, and the gradient descent. So that's what I give you one of the code. I wanted to show this, then you can understand. So 1 second, I'll go ahead and have a look at this. We just now we discussed. Okay. So every time, let's start. The slope is generates from the intercept is created from zero or not. We keep on change the intercept. Now just go back. We keep on change the intercept and finally we reach the best fit line or not. We keep changing the intercept. What is meant by that? That means look at the graph, guys. Look at this graph. Look at this graph. So here the b equal to zero. B equal to zero means what? Intercept is zero. So this is what we got. Now next point. Now b equal to 0.02 means intercept is increased to 0.02 and we got the line here. Next one, is this best fit line? No, this is not best fit line. The reason being all the points are very far and there is a huge loss functions. There is a huge error. So you cannot say this is a best fit line. Next step, 0.02. Okay. And then now slope is keep increasing here. And finally we reach the global minima. But here I wanted to ask, have a look at this, guys. What happen if we do a equal step? What happen if we reach to the, can we reach the global minima? If we mention learning rate, if the step count is so big, we cannot reach the global minima and it's overlapping, right? In first iterations. Second iterations, the step count is reduced. So what happened when iteration is, I mean to say that when iteration is take many time, the execution time is very late or not? The execution time is, so the model has to be trained within short period of time. If the trained model takes 2 hours, 2 days, and the user never get the goal or not. I mean, if you use any browser, if it's take 10 minutes to open a web page, will you use next time? No. So that's why we say the loss, I mean, this has very minimized. We need to minimize it. The learning rate is very, very minimum. So that's why when we declare 0.01. We declare 0.01. I hope understand everyone. So that's why, which one is greater? Which one is good? This one or this one? Second one. So we cost reduce to increase the good accuracy. I hope everybody's understand what is gradient descent. Anybody have any questions, team? Anybody have any questions on the gradient descent part? Iterations means, let's assume, I will get back to you what is meant by iterations here. You don't understand learning rate? Learning rate is it's nothing but the step count from one cost functions to other cost functions. From whether both are equal? No, both are not equal. Learning rate and learning rate we need to define as a parameters. Cost functions means for the one constant line, this is the cost functions, isn't it? If the line is changed to 0 to 0.25, another cost function is residuals is generated. What is learning rate? Learning rate means from one cost to other cost, the step should minimize. That's called learning rate or momentum. Yes, Ashi? I hope understand. Okay. All right. Now I'll give you, so GD we cleared. What if we don't get global minimum? Which point should we consider? No, you have to get, definitely. If you plot the 3D, you have to get. There's no options to not get. If no, there's a not valid questions. You will get global minima, definitely. But yes, if the data set is classifications, then only you not get global minima, because in classification we haven't used this algorithm. Yes, Rahul? Okay, good. Okay, I'll give you a small program that's saying without using sklearn how to write global minima. That's not important, but still I wanted to explain. And once we explain, then we heading toward stochastic gradient descent, then we heading toward batch gradient descent. What is stochastic gradient descent? What is batch gradient descent? We understand. But before that, just one moment. Okay. Just one moment, I think. Do we have gradient descent here? Or maybe I'll give it to you. Just 1 second, guys. I have one of the concepts called. Just 1 second, guys. Okay. No, I think I will explain tomorrow, or I'll share the link. You can check that out. Okay. That's not an issue. So I don't want you to practice that. I want you to know, because in machine learning, in deep learning, we use this gradient optimizer a lot. In deep learning, when we build TensorFlow, we need to mention as optimizer. There is a parameters called optimizer. So what is the optimizer? In deep learning, we have few optimizer: Adam, AdaGrade, error delta, RMS prop, okay? And then we have gradient descent, then we have stochastic gradient descent, then we have batch gradient descent. So in deep learning, we use these optimizers, gradient descent. So now everything is taken care by the code, guys. Everything is taken care by sklearn. So what we do, we need to understand the concepts to speak in front of the interview. That's it. Are you clear? In interview, someone asks you what is gradient descent. We cannot say, sir, in sklearn you can type optimizer. Can you say this, guys? No, but you need to tell them how we need to implement in this one. So that's the reason I'm giving you this session today. So are we learned today? What is gradient descent? What happens if we take a small data set? We have x-axis, y-axis, and we take care and we try to minimize we plot the cost functions, and every steps the cost function is reduced, and we're trying to reach the learning rate, and should be very, very minimum to reach the global minima. But my question is, look at this, guys. The math which I told you right now, in our example, we only had 3 data point. So the math didn't take very long, isn't it? Yes or not? In the data set, we have how many data points, guys? 3 data points. That's why the math didn't take very long. So in real time data, do you have only 3 data points? No. Assume, but when you have millions of data points, gradient descent takes slow or not slow, guys? Very, very slow. Assume when you have 2 lakh records, do you think 2 lakhs times we need to compute residual? It takes more time. So that's why. So there is a thing called stochastic gradient descent that uses a randomly selected subset of the data at every step rather than full data set. So I just want you to let you know, team, for big data, the gradient descent is very, very slow. So there is a concept called stochastic gradient descent. Are you clear, guys, what I'm trying to say? I mean to say that assume you have 1,000 records. Assume we have 1,000 record. See, guys, today the concepts which I am teaching, the name of the concept called gradient descent. We don't have any specific practical for it, but in every algorithm, we will use this gradient descent as a parameter, as a parameter. I hope you understand what is parameter tuning and what is hyperparameter tuning. I understand. That's why we need to understand. In GD, you can learn in ensemble technique, and also deep learning techniques, guys. Also, deep learning technique, we need to implement it. We need to implement it. That's why we need to understand. Now, if you have 1,000 records, if we have 1,000 records, if we compute 1,000 time residual, it takes more time or less time? It takes more time, because 1,000 time we need to compute residuals, which is not possible. So that's why let's heading toward stochastic gradient descent. What exactly stochastic gradient descent do? Rather, it take all the data points. It will take random points. Fantastic. What we take, guys? Random points. Assume you have 1,000 students, okay, and you cannot make 1,000 rows, isn't it? You take a random students and pick one group. Random points, it will create a one group. It will create one cluster. It will create one cluster or one group. Then it will start compute residual. Then it will start compute residual. Guys, in XGBoost, there is an algorithms called extreme gradient boosting. What is the algorithms, guys? XGBoost. In XGBoost, the learning rate is very, very useful. the learning rate is very useful. Random forest, the learning rate is very useful. So please understand each and every concept is connected with other. So gradient descent is mostly comes up with, I mean, linear part. So let's minimize what is stochastic gradient do. Let's have a look at this. Stochastic gradient descent. In the stochastic gradient descent, now, okay, but before that, one moment. So for big data gradient descent, it's slow because we need to compute all these loss functions every time. For example, if you have like more data points, let's build, if you build logistic, then you have 23,000. Forget this. I'm just wanted to give you some examples stating. So assume 23 terms to for each and every steps is compute mathematics, guys. So it's highly impossible. So that's why gradient descent is implemented. So big data gradient descent is slow. You can ask the students who learn data science in any of the institutes, whatever you take, ask them why big data gradient descent is slow. You can ask. Understand, guys? Then you can realize what is the reason. And here, what exactly stochastic gradient descent do? Stochastic gradient descent do, it will take a cluster by random of the points. So rather than assume how many data points we have, 1, 2, 3, 4, 12 records we have. In gradient descent, how many times we compute math? 12 time, isn't it? How many time, guys? 12 time, because we need to calculate the residual, each and every data point, one, then we generate a cost. Here, I will take a group cluster 444. Means how many times the math is compute? 3 times. Which is faster? 12 time is good or 3 time is good, guys? 3 time is better. So I meant to say that now let's plot. If I plot the best fit line with constant 0, now can we get a cost functions or not now? But how to compute? If we have clusters, I will take a centroid. I will take a center. Isn't it, guys? I will take a from center. This is actual, this is predicted. This is actual, this is predicted. This is actual, this is predicted. We got one cost functions. Now, the same way, let's increase the cost to 0 to 0.25. Can we get another one? Can we continue that or not? Team, I hope understand online, guys. Yes. So here, for example, if we have 12 data points, yes, it is equally distributes. So we have 12 data points, but there is a lot of redundancy that forms 3 clusters. That forms, if you have 1,000 data points, you can make it 10 clusters. Every cluster is how many points? 10, 10, 10, 10, 10. 10 into 10 equal, 100, sorry. 100 into 10, which is 1,000. So let's understand this one. So do you see same thing I was talk about it? So we start with line intercept 0 and slope is 1. Can we compute the formula the way I compute in the gradient descent? So go to the next one. Now next one. And finally, we'll create, we get to try to, so this is all math, guys. No need to understand in depth because we are not going to be researchers that we try to understand how exactly happen. Okay, guys. So very simple. We buy the car, we drive. When the problem comes, that time the problem will fix, isn't it? I mean to say that this is all math, but packages take care of it. In the training sessions, that's why you need to understand the concepts to clear the interview, to clear the question on gradient descent, learning rate, momentum, residual, cost functions, loss functions, and all those things. Clear? Now, next one. So did you just now we talk about it? And finally, I will try to reach the global minimum or not? Have a look at this, guys. Just one moment. This is all math I define, but you never understand. But I don't get into deep. But I'll share this one. Don't try. Just main concepts part explains you. Main concepts part I explains you. Now, same with gradient descent. So today we cleared if in interview someone asks you comparison between gradient descent, SGD. What you say, guys? But yes, even though if you have 1 lakh row, you can use gradient descent. But let me tell you also, listen to me, guys. In real time job, the moment when we work, so far, we build how many models? Two models. Every time we build the model, we train the model, right? It will take only 2 seconds to train the model or not? But in real time, it would be take only 2 minutes. So the interview questions is in your organization, in your organization, when you worked as data scientist, what are the challenges? What are the challenges or what issues you faced while train the model? By the way of your answers, I can recognize are you genuine or are you fake? Are you guys understand or not? What is my question? My question is we build two models in last week. When I train the model and when we fit and transform, it will take how many minutes? Only 2 minutes or 2 seconds. In real time, it is not possible. It never take 2 minutes. Sometimes it will take 24 hours. Sometimes it will take 12 hours. So that's the interview questions. The interview question is when you mention maybe you some of the experiences are there. So they'll say last 3 years I'm working as a data scientist, isn't it? Actually, they're not worked, but not you. Everybody present the same things in the world, guys. Okay. So when you mention, definitely they will ask these questions. If no one trained you in the training period, what answers you will give? Let me know, guys. And how frequent you train the model, I will tell you when the times come. How frequently, based on the flow of the data. In IRCTC, every day new passengers are logged into there or not? In IRCTC, every day the model is trained. Are you understand, Yamini? Because that's why every day midnight 11:30 to 12 p.m. IRCTC app is down. How many billions customers we are in India? Maybe 170 crore. How much, guys? 140. Let's say 150 crore. 150 crore. What is 1%? Might be like more than crores only, right? If 1% people log into the IRCTC, it is a big data or small data? For big data, model has to be trained every day. Understand? So that's why every day the IRCTC app is down at midnight. You try, you try. Your phone pay, your GPay, also they will stop the server to train the data. You understand? It could be many things, guys. So why I give you this example? Yes, Yamini, I hope understand. Based on the data flow. So assume in the production server, what is application server versus production server? Everybody must should know. And I have one practical part for it. I will show you. Okay. Every production server in a day, every day, the model has to be retrained. The model has to be retrained. I will tell you, Yamini, most of them has no idea about it. So it will take some time them to understand. Once we covered up, we'll talk about it. So assume the answer is, so in you, when you work as data science, what are the challenges? I will tell you the answer for this question is, sir, whenever I will use learning rate parameters, what do you say? Learning rate parameters, at that time, my model slow down, train will slow down. And I remember it took me one day, 24 hours to retrain, 24 hours to train the model. So yesterday, while we built simple linear regressions to train the model, it required how many? 2 seconds. When we pass learning rate, it will take 24 hours because if you have 1,000 records, every records it will pass and slow down, calculate the cost functions. Math is done. So that's why sklearn is connections of data structures, algorithms, math, and it's a big stories, guys. Are you clear? So there's a two type things they ask this in interview, sir. Very good. They will ask, they will ask, they will ask another questions also. Assume your RAM is 8 GB. What is your RAM, guys? 8 GB. In 8 GB RAM, if you train 24 GB data, how do you train it? What is your answer for this? Anyone? Isn't it valid questions or not? In cloud. Okay. So the question is not in cloud, Yamini. The question is, yeah, cloud is another source. But the question is, you have 8 GB RAM. I don't have cloud. Let's assume I don't have cloud. So how do you train? Using batch. Very good. No, Sashi Prasanna, that's right. Using batch processing. What exactly we call, guys? If you have cloud, yes, your answer is correct. We can go with cloud as well. We can go with cloud as well. Batch processing. Are you can understand what is batch? The batch is, so here assume how many GB? 24 GB, right? In 24 GB, I split into like 6 batches. What is one batch contains? Then you have SQL database you can connect. Now every data batch, every batch you need to train. Team, I hope clear. Split the data into multiple slopes, or else distributed system, or else distributed system. What are the distributed system? Maybe we have DBFS or HDFS. What are the distributed file, guys? DBFS and HDFS, which is Hadoop, which is Hadoop, which is called Spark as well, or Hadoop as well. Are you guys understand? So Databricks, that's correct. So guys, these are the questions I will tell you. And also, if you remember, I post a few questionnaire along with answer sheets. Might be you not understand at this moment, and I'd request good job the one who completed, and it feel a lot of confidence to you. Yes, team. Yes, Singh and Yamini and everyone. Now I can say, did you see 1, 2, 3, 4? This one, right click and open link in new tab. This contains 1,000 interviews, guys. You never going to get any question and answers out of the box. Okay. I will normally give the first batch who assign the question and answers from the first month. Normally I assign the question and answers at the end. But now I want batch to more offers. So here, data profiling. What is data profiling? Concept is same, but the way of answering and the way of understanding is different, isn't it? So data visualization, syntax errors, standardization, handling null values, and how to deal with unbalanced binary classifications. See, the one who working as a analyst, they knows what exactly is all about. So you guys take it seriously. Very simple. In the world, nobody will be expert, guys. You get to know expert when you go for practical, when you go for interview. That's the reality. So what is difference between box plot and histogram? Did you see this one or not? Okay. And then describe regularizations method L1, L2. No need to worry, leave it at this moment. I'll do one thing. I want you to take all the printout of all these 4 pages, all the 4 links. What you do, take a printout. Whenever I'll explain any concepts, check all the questions. Today I covered gradient descent. Check, tick it, or mentioned one of the diary, whatever you said. Make a cheat sheets. I hope you heard about cheat sheets, guys. In 10th class, a lot of guys that take cheat and write down and copy. Some of teachers, caught you or not. Okay, so be careful. But this cheat would help you to crack an interview. Now, next one, L1, L2, I'll cover up maybe tomorrow. Neural network fundamentals. So at this moment, what is cross validations? What is select metrics? Is this Python development code? Now, my question is this Python development code? Some Tom Dick Harry comes, you says, you need to be expert at code, then only data scientist. No, not required. I don't want you to be expert. I want you to be understand the concepts and very simple expert at Matplotlib, Seaborn, NumPy, Pandas, and machine learning algorithm. That's it. You build the code. Everything is packages there. Go and search in Google. Tons of packages are there. New packages are born yet. Guys, are you getting me or not, guys? Okay. Explain precision, recall, all those things I'll explain. So no need to worry at this moment. Okay. I will share this Fanta adjusted R squads, isn't it? I was talk about it or not. How to how to avoid overfitting. Cross validation is one of the technique. I told you. PCA techniques. Okay. And I mean better fit even this is whether adjustment comes in each edition. So if you not whatever I covered, you speak, that's it. Did you see, since we are creating a multiple regressions model, in multiple linear regressions model, are we get R square, adjusted R squares or not? They also saying the same things, guys. Now here, what is NLP stands for? What is difference between random forest versus SVM? Comparison. Comparison, guys. The comparison is, let's say you're staying in the two house, one block developer guys come, he will check why your house is this, why your house is that. They will compare both the house or not, guys. The same way, why the algo. What is dimension reductions? Anybody tell me? Are we did I explain or not? What concepts? Priyanka Chopra, PC. Whenever they talk about dimension reductions, think about Priyanka Chopra. No, guys, don't think about it. I'm just giving you an example. PC, principal component. I understand. So look at this. Dimensional reduction is the process of reducing number of features in a data set. Am I did it tell you or not? What are the concepts? Eigenvalue, eigenvector. And it's very simple. It reduces overfitting, isn't it? Okay. It reduces, remove multi-collinearity. It becomes easier, such as 2D, 3D, to avoid skirts of dimensionality. Principal components. I covered what is naive Bayes so bad. I will talk about. In naive Bayes algorithms, what refers to Bayes. Okay. What are the drawback of linear models? Very simple. Do you think 50 small decision trees are better than a large one? Yes, very interesting question. 50 small decisions are better than a large one because they will ask all the tree models. We have few tree models. These questions are very important. Okay. So I know I've been worked in industry, people also working. We get to know. That's why I'm sharing some of the reality part. As I said, when you face a lot of issues while you train the model, when you note issues and all those things, guys. Okay. And okay, I want you to take a screenshots on it, maybe PDF or I mean print, and then go back and go for this one. GitHub, right click, open this one. This is very important. I would humble request before you go for interview, prepare well, and then go for it. Okay. So we complete two part, gradient descent and stochastic gradient. Can we go for batch gradient descent now? Can we go for batch gradient descent? Just one moment. Batch gradient descent. What is batch gradient descent? So I mean to say that what is gradient descent? Reach the global minima for one point by single iterations. Means every records to reach the global minima using every single records. In deep learning, single records means iterations or not? That's called epoch. In deep learning, we called as epoch or epoch or whatever it may be based on. Now, to reach the global minima using random cluster or group points is called SGD, stochastic gradient descent. SGD. This is called GD. But what is batch gradient descent? Anyone, guys? Group of no, this is also group of data point, right? But what is batch? Anyone, guys? So assume I have 1,000 records. How many records, guys? 1,000 records. In 1,000 records, let's say 1, 2, 3, 4, 5. If I take it to 100 batches, that means 1000 divided by 100. Every batch contains how many records, guys? 10. So it is in sequencing order or not? So 1 to 10 is one batch. 11 to 20 is another batch. 21 to 30 is another batch. 31 to, I'm just giving 10 records. How many batches we can make? 100 batches. Or if you divide it by 10, if you want to make only 10 batches, then it will give you 100 or not. So in gradient descent, single point we try to reach. In stochastic, we make a random. What is meant by random? Sometimes 1 is pick, sometimes 10 is pick, sometimes 20 is pick. That's called random. But what is batch? Batch is not a random. Batch wise. So let's say, can I build this graph like this? So here, I'll make one batch. This is one batch. This is one batch. This is one batch, isn't it? So every batch, let's start with intercept 0. And I get one residuals or not, or cost functions. Now let's increase the best fit line. Can we get another residuals, another cost functions? Can we try to reach global minima or not? Everybody is clear. So today we discussed, I know that many of them understand, many of them not understand, but still every sessions I'm writing to make you understand well, guys. All right. So here, to reach the gradient descent, to reach the global minima using batches. It's called batch gradient descent. Guys, are you understand? So that's why when you build deep learning model using TensorFlow, we have options ann.compile batch size equal to 32. By default batch is 32, optimizer, optimizer is gradient descent. Also you can pass. Means this concept is pointing towards deep learning. You understand why I teach you these concepts? I will get back practical at that time when I talk about ANN. But this is very important. I hope everybody understand. And I think I've pretty well explained this one, GD versus SGD versus BGD. Clear or not? In interview, if anybody asks, I'm sure you can speak any concepts from it, guys. And there's no practical. We use GD, SGD, BGD as parameter tuning. What is hyperparameter tuning? If I convert GD to SGD by default, as user request, that's called hyperparameter tuning. Are you guys, today we complete optimizer, gradient descent, stochastic gradient descent, batch gradient descent, we completed. So make sure these three things is very, very important. I want you to paste in one, the question bank, and this questions only you will encounter, guys. Are you understand or not understand? And yes, that's it for today, guys. And tomorrow I will start regularizations. I will complete tomorrow. And once I complete feature scaling, did we cover? Not. Feature scaling. Tomorrow I'll cover feature scaling, and regularizations will complete tomorrow. Once we complete, then we go back to the nonlinear algorithms, guys. Then we go to the non-linear. Linear regressions, linear, what are the concepts we've done? Simple, multiple, gradient descent, and regularizations. We complete two things. Time series, I'll explain later. What is time series algorithms? Difference between time series versus regressions is very important. Okay. So in regressions, we use how many variable? How many variables, guys? 2 variable. But in time series, we'll use only one variable, which is time, So univariate time series data, what we called univariate time series data, and every time series has some of the model. For example, let's assume today is Monday, tomorrow Wednesday, day after tomorrow Thursday. To predict Thursday weather, will you check Wednesday data or Monday's data? Monday data. You do stock trend, stock marketing. In stock marketing, you have some candle graph and reg graph, isn't it? So almost you compare with historical data or not. But maximum stockers, traders, they focused on yesterday's n equal to n minus one, n minus two. This algorithm's called AR, auto regressive. What algorithms, guys? Auto regressive. So all those things we covered one by one. Okay, just trust on me, trust on course, trust on your hard work, trust on interviews, answer confident. Think things definitely turned up. Are you clear? See you tomorrow. Have a good day. Okay. So excuse me, buddy. I'll talk to you. Just wait. Okay. Just 2 minutes. Yeah. Okay. I do appreciate someone who I think today's session is great. Why yesterday's session is not good then? Yes, Saurav? Not, man. Last week? Okay, I understand. Thank you. I know, I know. Okay. All right, take care. And yeah, Monday, I know it's a lot of work. Anyway, for you, no work, man. You don't nod your heads. You just for every day, it's a funny day for you. For the employees who say. All right, see you tomorrow and have a good day. Bye.